Modified box plot lets me find outliers if there are any. Why do I care about outliers?
They throw off the average.
Because they get thrown off the average. We are now testing an average. Thank you, Elizabeth. We are testing an average, which can be unduly influenced by outliers. Yeah? Yeah, we got to watch that. With proportions, it wasn't a problem because there is no such thing as an outlier with proportion. You either have something or don't have something. You can't, like, have something too much. It's a checkbox, yeah? It's a checkbox. But this, now it's a measurement, which means there can't be movement too far away from an average. All right. So the first thing I'll do is I'll do a real quick little window. Ooh, that's pretty good, actually. Let me futz with the scales a smidge. Make that 0, make this 40. Okay, it's getting better. Let's change this to 5. Maybe scooch it up a smidge more. Okay, that's what I end up getting. Any egregious outliers, friends? Any egregious outliers anywhere? Data's roughly bell-shaped. It's got some skew. It's definitely skewed a little left because of this guy, but then you got this guy poked out here, so I mean, it ends up balancing pretty well. We can test it for skewness. I don't think you want to. That's okay. We just look at it. The biggest thing I'm concerned about is an outlier point. That's the biggest thing. If we were got somebody going 75 down the road, it's hard to talk about that point, that 75. Well, first of all, they wouldn't make it down the road going 75 down Archie Briggs. But also, it's kind of hard to talk about using that as a realistic data point for this data set. Well, that didn't happen, so I think we're okay. Good so far? And you can futz with the windows some more if you want to change the scales on things. You can break them up a little bit, but it's not going to change too much from where it already is. All right, beautiful. So we can live with this. We can live with this. So, next question. What claim should we test? Because we're at step 3 now, right? We're at step 3. What claim should we test, in your opinion? We know we're going to be studying the average speed of the car, of an average speed of a car on Archie Briggs. What do you think we should test?
Well, the speed limit's what, 30 miles an hour?
Speed limit's 30.
So obviously you wanted to know how many is going over 30.
Good! Very good, Chris. So I just ran a real quick average. On the data. I get an average of 31.7 miles per hour, yes? That's just real quick based on my data. Hopefully you guys did the exact same thing I do. There's your standard deviation. So the average is a smidge above, yes? It's a couple miles an hour above. But when you look at the data, you can't help but notice, percentage-wise, 30 people were going 30 to 35, and 27 people were going 35 to 40. That's a big chunk of the data set, right? There are 83 points in that data set. And you're talking about almost 75% of them are in that 10-mile-an-hour block, which seems to me to be over 30 miles an hour, right? And there's all kinds of rules you get told by your friends, lies. Oh, the cop won't give you a speeding ticket if you're going 5 over, or what is it, 7 over, 9 over. I Googled it in Portland. The rule for unsafe speed, oh poop, I've forgotten it now. It's anywhere from like 6 under to 9 over. That's like the safe zone. And if you're outside that range, you can get a ticket for unsafe speed. But I mean, all these are somewhat arbitrary. The question is, statistically, is that and or that reason to see that they're speeding? So is that an okay claim to test? Can we test to see if they're speeding on average? Statistically, significantly? I don't want you to look at that and go, it's only 32, dude. A cop's not going to give you a ticket for 2. Don't worry about that. That relies on former knowledge, correct? That relies on former information. Is that statistically significantly higher than 30 miles an hour? That's what I want to know. Does that sound fair, with Chris's claim? I think it's a good one. Yeah, I think it's a good one. Good. Let's turn this off for just a sec and get some hypotheses written down, yes? So we're testing the average speed of a car on Archie Briggs. Chris's claim, which I love, and it sounds like you guys do too, is I think they're speeding. I think they're speeding. I think they're speeding. Fair enough? No, they're not. Do realize that you can get a ticket for going too slow as well. Some roads actually mark it, minimum speeds. Very few, but some do. But even if it's not marked, I remember I used to work as a court clerk years and years ago when I was in high school. I filed papers and stuff like that, and I typed up dockets. And I kept typing up thing for unsafe speed. I thought that was so dumb, because you have a ticket called speeding. Why do you need unsafe speed as well? That's when somebody explained to me, you can get a ticket for going too slowly as well as going too quickly. You don't often, but you can. And then they also explained to me that unsafe speed is more of an officer's discretion kind of thing. Like today, if you were going the speed limit on College Way today, you might get a ticket. Because due to the conditions, the speed limit is actually unsafe because of the icy conditions, especially on COCC's campus today. So, not that there's a speed limit on campus, but actually, is there a speed limit on campus? There's gotta be, right? Like on the parking lots, like 10 or something like that. Chris!
I have a question. I remember in high school, people would often say, and I don't know if this is true or not, in
Sure.
Oregon, we don't have speed limits, we have suggested speeds. In other states, they actually put the word limit on the sign. And here
well,
they don't. And I was
I
like,
think
yeah,
that's
right.
because when they printed the signs, we were in a low budget year, and they couldn't afford the ink. I have no idea, Chris. I have
I
no
don't
idea.
know.
It would not surprise me in the least, because I just found out, relatively recently, U-turns are illegal in this state,
Yeah,
unless they say you can make them.
unless it's posted.
Unless it's posted, you can make them. So then I saw a sign that said no U-turn, and I'm like, that's confusing.
I know.
By default, you can't make a U-turn. Why does this say I can't? Then I started second guessing myself. So anything is possible with Oregon traffic law. That's my very cloudy answer. But as I'm living here more,
If you have two negatives, then you can actually do it.
you can. Well, explain. So if you would explain this one to me. Driving down the road, we all know what this means. Yes. So that's yellow. We know what that means. If you're on this side, you can pass. If you're on this side, you can pass.
Yeah.
What does that mean?
You can't go over it.
But why would you have the dotted line in between?
Oh, when there's
It's
two
lanes.
solids and there's
Oh.
Two
dotted-
solids and a dotted line.
and that's in the middle.
That is on Highway 20, moving east out of Bend. A good chunk of Highway 20 has that paint. Next time you're driving Highway 20 when it's not covered in snow, take a look. You'll see them. Is that just somebody forgot to paint over the dotted lines, or does that mean something in Oregon?
That means you can cross if you need to turn left.
Really? You're making that up right now. I totally go with you. Don't mess with me like that, Elizabeth. I think that means something. Shit if I know what it is. Okay, so you do that. Okay, good. If anybody has an idea, I'd love to know what it is. Okay. We got ourselves hypotheses. Let's test them, yes?
It's all ODOT.
I don't want to talk to ODOT. I've tried that in the past. Doesn't work. Okay, so basically, essentially, what we're testing, I'm going to draw a little picture to go with this. What we're testing is this. This
30 miles.
is 30, exactly. That's 30, which will become a T-score, which is going to be normalized to 0, if we normalize it. We landed somewhere to the right of that. We saw that from our data, right? Our data came up above 30. The question is it far enough above 30 to be like, okay, now it's statistically significantly above 30? See the difference there, friends? Does that make sense? So the question really, as it always is in this class, is how far out this way. We know it's out this way because it was 31.6 was the average. But we can't just go out 1.6 and put 31.6 out there because we don't know what the ruler we're using is. It's all about the markings on the ruler. There's an hiccups. There's an invisible ruler on this axis. And until we actually run the test, we don't know what the ruler's markings are. It's all about the standard error, right? And calculating that can be a bit of a challenge. That's why I let technology do it for us. But the question is, where does 31.6 go? And what is the corresponding t value that goes along with that? That's really, honestly, what questions 7 and 8 do for us, right? That's what questions 7 and 8 do for us. They give us that answer, or those two answers. But you notice I have questions 4 through 6 between that, of course. Because I like to look at this, I'm kind of like a DO when it comes to statistics education, more than an MD. I look at it holistically. I also want to know why, how you can mess up, and which way you would rather not mess up. So first of all, let's define some errors here, yeah? Type 1. What would type 1 be? False positive, good. Love that. Give it to me in context.
Saying people are speeding when they're not.
You're right. Saying people are speeding when they're not. Saying people are speeding when they're not. That's a false positive. Crying wolf. Oh my God, a wolf! No wolf. Therefore, a false negative would be type 2.
Saying they're not, and they
Saying
are.
they're not speeding when they actually are. Thank you. Saying they're not speeding when they actually are. In your opinion, which one is worse? And just circle one. And you tell me why you think that one is worse. What do you think?
I'm saying there's.
Type 2, type 2, type 2. Tell me why, guys.
Speeding's dangerous.
Speeding can be dangerous, yes, if they are speeding and you're not seeing it. If they're speeding and you're not seeing it, then you're letting people go down the road too quickly. And if that speed limit is safely set to be 30 for a reason, you're creating a potential unsafe. Good, good. Now, Chris, you said type 1, didn't you?
Yeah. 'cause-
Good, tell me why.
Well, if you say they're speeding and they're not, then you're getting a ticket and you
Good.
shouldn't be getting.
Oh, good. You're actually even thinking from a financial. Good, very good. That's Elizabeth's saying yes. I agree with that too. Or maybe if they, as a result of the test or the analysis, we say they're speeding, we knock the speed limit down even further, and now it's unnecessarily dragging people through. I deal with this in major metro areas. You do too. Whenever you go to major metro areas, when you suddenly stumble upon a section of controlled road that is so poorly controlled that you're in it for like 20 minutes. Lights are synced wrong. You know, you catch every red when they should be synced to catch every green. I mean, there's all kinds of false positive problems too. Good. So there's no right answer for that, right? You pick whatever one you think is worse and why. Good. Thank you. Thank you. All right. Which distribution? We already answered this kind of, didn't we? No, that's T. Absolutely. So that means your test statistic is going to have a T equals on it. And now comes the fun part. Now we crunch the numbers and we see where everything lands. Right. Up to this point, it's all just been talk. Let's make it action. All right, let's get our data's in. Beautiful. T-test. Now you just got to make sure you set the screen up correctly. We have data, again. We're testing against the mu of 30. Yes, sir. Yes, ma'am. Data and frequency are in L1 and, oops, gotta get down here, L1 and L2. Just make sure you pick the correct sign. Right now it's testing less than, we don't want that, we want greater than, yes? We want greater than. Basically make that sign match your hypothesis, your research hypothesis, and you're golden. Another reason I like the template. Cool? You guys like draw or calculate? Yeah, I think draw is nice because it gives you exactly what you need plus a visual, which I really do like about it. All right, here we go. Here it comes. Okay, look for area over here. That's where the p-value is going to be, is area over here. Okay, a little bit, a very little bit. There is area, but not much. Right? 0.0085. So now you've got two, you have two, 7 and number 8. You've got those two questions answered. Your test statistic is what?
2.4386.
Right, exactly that. T equals 2.4386 or 2.4 or something like that. Vice Brandon, thank you, sir. What does that mean? Where did our data land?
Almost 2.5 standard deviations away.
You should always think of it that way. That is a standard deviation measure. You now know what your ruler looks like. You know that this was 30. This was 30. 31.6, which was the sample average, landed 2.5 standard deviations away. That's what that tells us. Standard deviations. We've normalized it down. We know this bad boy is 2.46 standard deviations. That means 31.6 landed. This is a very, very long distance. That means the standard error must be exceptionally small. And that's because, why? The standard deviation in the sample was 6 miles an hour. Why is the standard error so small? It's far, far below 6. If you don't know the answer to that question right now, don't worry. We'll come back to it with the second. Brian, you know it?
Well, I'm thinking just by the number of samples.
Sample is huge. I sampled 83 cars. And you gotta remember, I say you gotta remember this. You don't have to remember this. But there's a reason why it gets driven down. Standard error for this particular thing you're crunching right now is given by your sample standard deviation divided by the square root of n. As n gets bigger, Chris, you taught me this 6 weeks ago. As n gets bigger, what happens to your margin of error? As n gets bigger, what happens to your margin of error? It shrinks. That's why. Because there's always going to be an n in your denominator. There's always going to be an n in
You
your
told me that a
denominator.
year ago.
Say that again?
You told me that a year
I
ago.
did, and you learned it well, brother, because you taught it to me 6 weeks ago. I have no memory, thank God. So that's why this is so far out. That's why our p-value is so damn small. There's not much area left. That's the area that's left. Only less than 1%. So that's number 8, 0.0085. Yes. Yes. So how about number 9? What does it look like?
People are speeding.
It appears people are speeding. Now I know we can get into a fist fight here. I don't want to because you guys kick my ass. But the fist fight we get into is like, oh, rule, the average was 32 miles an hour, the speed limit's 30. Are you seriously gonna make me say they're speeding going 32? I'm like, yeah. Because what am I testing here? Am I testing practical significance?
Yeah.
What am I testing?
Average.
Only, what kind of significance? Statistical significance, right? I can make any difference significant if my is Fill in the hms.
If your sample is you.
If my sample is 2 hms.
2 standard deviations away from
That's too many hms. I can make any difference. For example, suppose the speed limit is 30 and my sample average came in at 30.5. That's
only 2 cars.
Well, hang on now. No. If the speed limit is 30 and my sample data comes back at 30.5, nobody in here is going to say that's statistically significant, are you? Can I make it be?
If your sample is tiny.
If my sample is large enough. If it's large enough, I can make 30 and 35 do the same thing 30 and 31.6 did, can't I?
Yes.
If my sample was very small, this would come back and be very close to 30. But the only reason it's so far away is because my sample is so big. I can make 30.5 be significant by just drawing enough cars to stretch the standard error out. All I gotta do is make this make this as small as possible by making that as big as possible. Inverse proportions, yes. Now, I'm not saying it's practically significant, but I can make it statistically. That's why you guys have to look at the context of any publication that you see.
So by increasing the sample size,
Yes,
you can make the
I can make anything significant
Right.
by increasing the sample size large enough. Go, Brian.
Well, I was just going to say, well, then you could technically make any data fit what you're looking for.
It depends on what you've defined to be what you're looking for, right? Because we went from, if you think about it, we went from speeding to exceeding 30 miles an hour. Now that's not the same thing. Speeding has a connotation that goes with it. You're going to get a ticket for speeding. Exceeding 30 miles an hour simply means whatever speed you're going is numerically greater than 30 miles an hour. That might not be speeding. You see what I'm getting at here? But that's the difference between a contextual answer and a statistically significant answer. I can't teach you practical in this class. That's where your guys' degrees come in, yes? That's when you take this and you put it into your fields. All we can do with a toolbox. Using the tools, building something with the tools, that's what you do once you leave here. So that's why I implore you, read the context of the articles you're reading. When they say things like caffeine is good for blah, 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 what's defined to be good, first of all? What did they measure? How much greater is it? Maybe it's statistically significant, maybe it's practically significant. Maybe they just, because they sampled 40,000 people and they saw a 0.1% drop in a rate of something. That might be significant. With 40,000 people, it wouldn't take much to be significant, right? But also, it might also not be worth the trial. The context. That's why most of the questions on this aren't math questions. They're context questions. For example, the last one. Could we have made an error with this? Could I have made an error with my data? What kind? The only one right now I could make is type 1. Because I got a small p-value. That means I said positive wolf, wolf. Now maybe there's a wolf there. I.e., maybe they're speeding. Yes? In which case it's a true positive. But maybe there's not. Maybe I just got slightly deviant data randomly, and I'm crying wolf, which would be a false positive. That's what Chris said he would like to avoid as much as possible. Yes, sir? You want to avoid a type 1? You might want to test it higher than 5%. Or excuse me, lower than 5%, higher than 95% confidence. You might want to shove that significance out as far as possible before you run the test. Okay, just keep that in the back of your mind. That's part of your last project. Cool? Questions? You got the questions? Fair? Decent?
So since it was less than 5, we decided that it
Yes.
show that
That is
they are
the, thank you, Elizabeth. That is the marker we're using for the rest of our time together. Now, I'm not saying it's always the best, and you'll see that in your last project. It's not always the best to use 5%. But just to make our lives that much easier, let's always test versus 5%. Is that okay? Good. So we're always looking at that p-value, which is now off. We're always looking at that guy right there and trying to metric him versus 5%. 5% is a line in the sand beyond which we have gone. The line in the sand is like, okay, it's kind of like, I'm trying to think like you play with your friends, like, do it again, I'll punch you in the face. Well, he just did it again. So now you're going to punch him in the face by saying it appears as speeding. Just punch him in the face. Fair? Good? Decent? Sorry, these are the jokes. They're not very good. They get recycled.
So when exactly are you gonna explain the power though, and how it correlates to that?
That's your whole last project, is that.
But
The power idea. Honestly, to include that in class 2 with these tests would make each test go on for hours and hours and hours. And honestly, the reason, that's a bit of an evasive answer. And here's the deal. When you look at the outcomes for this course, it says, teach type 1 and type 2 error. That's all it says, teach type 1 and type. I could devote 5 weeks of this course to explain to you guys how to calculate power. And I decided years ago to try that. It was a huge, huge mistake. It drove students nuts. Because the calculations for power, this probably seems a little bit touchy-feely to some degree. Like it seems kind of ethereal. There's some, we're pulling these hypotheses seemingly out of the air, although they're not. They're based in fact. Calculating power requires you to pick an alternative value of the hypothesis. If it's not 30, then what is it? So then you have to go like, what if it's 32? Well, I don't like 32, I want 33. I want 35. And that's where I started getting into fistfights in class. Because you have to pick an alternative value of the research hypothesis and test against that. And it was driving students nuts. So this project that you're going to look at for 2 weeks from now, or whenever it's due, actually allows you, without doing the calculations, to see the interplay of the power and the confidence by moving sliders around in Excel. So when you say power, you meant that, right, Brian?
Well, that's what I want to see, I guess. I want to be able to visualize.
And you
as well.
will.
Okay.
That's what the project, your project has 5 spreadsheets accompanying it. And I apologize, but I had so much fun. I'm like, this is gonna be great. The first one I'm super stoked about. It has 2 sliding bell curves. You'll get that one. You'll be like, okay, it all makes sense now. It's the one. It correlates to what I drew on like the first couple days of class,
Right.
but now it's dynamic, so it moves. And I was pretty proud of this. The last 4 are you doing an informal hypothesis test to decide if data coming in is showing significant deviation from an expected average. Now, you're not going to actually run the test. You're simply going to hold down F9 and watch this coin bounce around and then stabilize and then make a judgment call based on where it is. So you'll see it. I'm teaching type 2 error as per the requirements of the course, but we're learning it intuitively versus formulaic. See, type 1 error is easy because you guys understand confidence like that. What you don't understand clearly, and that's because it's only 10 weeks long, is the fact that there's a second curve. And we're talking about that second curve right now. Theoretically speaking, we're talking about that second curve right now, right? This is where we landed in our study. That means it's hard to believe this is our curve, isn't it?
Right.
It's easier to believe there's a curve over here. But I always take the cheap shot and I draw the curve right over top of the test statistic. What if it's here? What if it's here? That's what your project's all about. Let's just slide that curve around. Without doing it arithmetically or algebraically, just grab this slider and pull it and watch the curve go like this and this and this. Crack it open, take a look. I think it's going to answer your question. I hope. It was a fun one to make. It took me 7 weeks to write the damn thing. And I'm glad that snow day happened on Friday because I actually could finish it off on Friday. So, but I think your question's going to be well answered in there. Fair?
Yes.
And only because, Brian, I've been teaching this class for 10 years, and whenever I try to bring it into the class, I used to have a power project, and students were doing really well on it, so I'm like, okay, cool, I'll bring it into the class. Huge mistake. Leave it as a project. It seems to work better as a project. So that's why I started shuffling projects around. I made you guys do a confidence project as a quiz. The one where you guys, the mandatory quiz you guys did, that used to be a project. That was very, very straightforward. You guys all got 10s on it. Hold that F9 button and write down some numbers. But that's why that power project got shifted back, because that's when students seem to enjoy it the best. I think you'll like it even more. I'm curious to see what you say on the last day of class when you come in and do your surveys. You might come in with weaponry, maybe. It's possible. I hope you enjoy it. Hey, let's take 5! We're way over our, holy, yeah, we're way over. We're 10 minutes over, I apologize.